Today, we're going to unpack an incredible story that sits right at the intersection of love, desperation, and some seriously cutting-edge technology. It's about a data engineer, his best friend, a rescue dog who was given just months to live, and how he used AI to orchestrate a groundbreaking medical intervention to save her.
So, meet Rosie. She's a Staffordshire Bull Terrier Shar-Pei cross. In 2024, she got some terrible news, a diagnosis for a really aggressive form of mast cell cancer. The prognosis was just awful. Vets told her owner she only had a few months left. And her owner, well, he tried everything. Chemotherapy, surgery, he spent thousands of dollars. And while all those conventional treatments did slow the cancer spread a little bit, they just couldn't stop it. The tumors, one of them the size of a tennis ball, just kept getting bigger.
But Rosie's owner, Paul Conyngham, was not ready to give up. Now get this, Paul is a tech entrepreneur. He's got 17 years in machine learning, but absolutely zero background in biology or medicine. None. But that didn't stop him. He decided he was going to take on the cancer himself, using the only tools he really knew, data and AI. So, you have to be wondering, how does a data engineer with no medical training even begin to think about tackling something like this? Well, it turns out he approached it exactly like a data engineer would. He built a pipeline, a step-by-step journey from raw data all the way to a potential cure. Let's walk through the process he built, because it's pretty amazing. It all started with research, actually using ChatGPT as a kind of assistant. From there, he got the raw data by sequencing Rosie's healthy DNA and her tumor DNA. Then he used powerful AI like AlphaFold to actually model the mutated proteins. And this is where it gets really cool. He then built his own algorithms to pick out the best targets for a vaccine. After that, he teamed up with scientists to actually make it. And finally, he had to navigate all the complex ethical approvals to get the vaccine administered. What a journey! So step one was getting the data. Paul reached out to the Ramasiati Center for Genomics at the University of New South Wales. And, as you can probably imagine, his request was, well, a little weird. Associate Professor Martin Smith, the director there, remembers thinking it was a total oddball query. I mean, they don't usually do direct-to-consumer gene sequencing, especially for someone who has no idea how to even read the data. But Paul managed to convince them. He basically said, "No worries, I'm a data analyst and I'll figure this out." And the goal, in concept, was pretty simple. Get a sample of Rosie's healthy DNA and a sample from our tumor. As Paul explained it, it's like comparing your car's original engine with that same engine after 300,000 kilometers. You can see exactly where all the damage is. And those points of damage, the mutations, that was the key. So with the raw genetic data in hand, which cost him about $3,000, Paul got to work. He used data pipelines to find the mutations, but then he did something pretty remarkable. He plugged that data into AlphaFold, Google's AI, to actually see the 3D structure of the rogue proteins the cancer was making. He was literally translating abstract genetic code into a tangible enemy that he could target. Now, this is where Paul's specific expertise really shines. He didn't just use off-the-shelf tools that were already out there. No, he built his own machine learning algorithms to sift through all those mutated proteins and pinpoint the absolute best ones to target, the ones that were most likely to get Rosie's own immune system to fight back. Okay, so with his targets identified, he had the recipe for an mRNA vaccine. You've probably heard of this tech. It's the same kind used in some of the COVID-19 vaccines. It basically gives your cells a most wanted poster. It teaches them what the enemy, in this case Rosie's cancer cells, looks like, so the immune system can go hunt them down. He sent his half-page formula over to Professor Paul Thordarson at the UNSW RNA Institute, who actually agreed to make it. All right, so the vaccine is made, the science has been done, the code has been written. But the biggest question of all is still hanging in the air. Is this actually going to work? This is the moment of truth. So after a 10-hour drive, Rosie got her first shot in December 2025. And the results, they were just staggering. Just look at this progression. You can see the large tumors before the treatment. And then, just 1 week after the first shot, and then into January and March, you can literally see the tumor shrinking. The biggest one, that tennis ball-sized tumor, it shrank by half. It was actually working. The reaction from the scientific team, the same ones who took a big chance on this oddball query, was just pure astonishment. Associate Professor Martin Smith, who was pretty skeptical at the start, put it perfectly. It was like, holy crap, it worked. That's the kind of raw, unfiltered reaction that tells you just how incredible this result really was.
And let's be really clear here. This wasn't just a huge win for Rosie and Paul. This was a historic moment. The experts who were involved, people like Professor Thordarson, confirmed that this was the very first personalized cancer vaccine ever designed for a dog. A massive milestone, and it was orchestrated by a computer scientist.
Now, it's really easy to hear this story and get carried away, to say something like, wow, AI cured cancer. But, it's a little more nuanced than that. What this story really is a powerful example of citizen science, but it was a success that was totally dependent on collaboration with human experts.
Let's break that down a bit. Think of AI as the ultimate enabler here. ChatGPT was like a research assistant, AlphaFold modeled the proteins, and Paul's own algorithms crunched the data. But the human element, it was absolutely irreplaceable. Paul provided the judgment, the direction, and that relentless persistence. The scientists at UNSW brought decades of deep expertise in the lab facilities, and Professor Rachel Alavena at the University of Queensland navigated the super complex ethics to actually give Rosie the drug. AI was the accelerator, but humans were still in the driver's seat.
Professor David Thomas, who's the director of the Center for Molecular Oncology at UNSW, really nailed the significance of all this. He pointed out that a regular person, a punter, as he puts it, with the right technical skills can now meaningfully contribute to the scientific process. That is a huge, huge shift.
So, beyond this one incredible dog story, what does it all teach us about the bigger picture? What could this mean for the future of medicine?
Well, here are the key takeaways. First, this whole thing suggests that personalized medicine can be done way faster and much more affordably than anyone thought possible. The entire process, from sequencing to vaccine, took just a couple of months. Second, it's democratizing innovation. These tools are becoming more accessible. And maybe most importantly, this isn't just for dogs. Companies like Moderna are already in human trials for very similar mRNA cancer vaccines. Rosie's story is like a real-world proof of concept for a much bigger revolution that's coming.
And at the end of the day, this is the result. This is Paul and Rosie today. Now, the treatment wasn't a silver bullet cure, but it has bought her significantly more time and maybe just as importantly, a much better quality of life. Just 6 weeks after her first treatment, she was back at the dog park with enough energy to jump a fence trying to chase a rabbit.
Ultimately, behind all the complex algorithms, the DNA sequencing, and the AI models, there was a really simple, really powerful motivation. Paul said it best himself. Rosie is his best mate. She'd been there for him through a whole bunch of tough times, and he was determined to be there for her.
Which really just leaves us with this final thought. Rosie's story is a remarkable one-off case, for sure. But it's also a powerful glimpse into the future. If one determined person driven by love can pull together these tools and these experts to achieve something like this, what's going to happen when this kind of power becomes truly democratized and accessible to everyone? What are the problems we're going to solve then?